Good morning once again, my dear lovely lions, my dear lovely NEET warriors. Welcome aboard. Hi Madhumati, hi Harbarine, hi Satyashri, hi Krishna. Good morning, Shobika. Yes, please watch the Newton's laws of motion. That will be better. And then probably watching this lecture will help you. Hi Atluru, welcome back. Good morning, all my lovely, amazing future doctors. It's time for circular motion after many classes of your RNA series. We are finally reached here, and NCERT line by line series is also simultaneously going on so that you have in-depth knowledge of your all the NCERT chapters and simultaneously the 11th portions in circular motion, guys. That's what we are going to do today. If you have missed any of the previous classes like work, power, energy, or maybe even Newton's laws, please watch it. It's there right on the channel. All detailed classes in a proper manner, using concepts, using examples, using applications, everything I'm teaching you right from the basics. Okay, so make sure you watch it out. This is your RNA series, Roar NEET Aspirant series, and this is none other than your Captain Shreyas Sir. Quickly smash that like button, quickly hit that like button right away, right now, to show your support, to mark your attendance, and subscribe right now. That's very important. Hi Disha, hi Sudharan, hi Daredevil, hi Vetri. Good morning, good morning. Hi Evening Star. Yes. Question solving sessions also coming very soon. Just hold on for some time. You will see only just questions and just question solving sessions also. So let me just complete as much theory as possible in this coming month. That's it. Then we will be going to the next phase, and then the revision phase, and then obviously the mock tests, and then the NEET exam will come. So I want your full support on the channel while you're watching these classes. Okay, so let's begin with the class. Okay, thank you for liking, thank you for subscribing, and thank you for sharing and talking about this lecture as well. So to start off with, basically circular motion is there some, in our everyday life in different ways, like a rotating fan. Our earth is also rotating, or maybe the hands of the clock, or a car going around a curved track, or maybe an aeroplane going around a particular region, or maybe just let's say a pendulum which swings back and forth, your joy rides, anything which rotates. All these are examples of circular motion. In fact, a drilling machine, or even your CT scan, MRI machine, also there is a thing which keeps on rotating. So your ball and socket joint, you can see this is just again rotational motion. My elbow is like a joint over here, or even my shoulder, ball and socket joint. Okay, again this is circular motion. So circular motion is there everywhere. So that's what we are going to study. Now, there are two main aspects of circular motion. One is the how part, how it is happening, which is called kinematics. The next is why part, which is the dynamics. So in the how part, you talk about velocities, acceleration, displacements. In the why part, you talk about the forces. You talk about the force which causes the motion. Why is it moving this way? How it is moving, with what velocity, how much time, how much displacement. Okay. Also, you will see circular motion will have another two categories. Like one is uniform circular motion, where things are relatively straightforward, and most of the times the problems are on uniform circular motion. Sometimes, some places you will see the body is non-uniform circular motion. For example, the hands of the clock, they keep on going at the same speed. So that is an example of uniform circular motion. Earth is rotating at the same speed. It takes every day 24 hours for it to complete one rotation. It's not like sometimes it is slow, sometimes it is fast. So that is the example of uniform circular motion. But when you switch on the fan, slowly the speed will increase. That is an example of non-uniform circular motion. or you brake a wheel, the wheel which was rotating fast will slow down. That is also an example of non-uniform circular motion. Or a pendulum going back and forth. Slow, fast, slow, again fast, again slow. So it is again non-uniform in nature. So all these things, uniform circular motion, non-uniform circular motion, how things are happening, that is kinematics, and why things are happening, that is dynamics. That is what we are going to study in today's lecture. Okay? Good evening, my dear warriors. Yes. Welcome, Madhumati. Yes. Hi, Arganeshri. Hi, Satyashri. Now, let's start taking up simple terminologies. Some of you also might have seen this wall of death in some circus or maybe some adventure place where biker or a car goes round and round in a wall of death and they don't seem to fall down, and it's a very, very dangerous sport, wall of death. Okay, even pendulum, all these examples I just gave you. Let's start with the basic terminologies. First is something called as the axis of rotation. So anything which rotates or goes around will have something called as the axis of rotation, like this earth right now. Okay, you can see there is an axis of rotation going from the north pole to the south pole. This is the axis. If I tilt it like this, that is the axis. Your door will turn about an axis, which is the hinge, which is basically the hinge where it has been attached. Anything rotating will always have some kind of axis of rotation, correct? Okay, so let's slowly start talking about the different terminologies. Let's start talking about the different terminologies of circular motion. Now, whenever things go in a circular path, it need not look like it is going in a circular. It might be any curved motion. It could be any random curved motion. This curve can be thought to be made of small arcs. And each of this arc, if you extend it, it will become a circle. If you extend it, it will become a circle. If you extend it, it will become a circle. You extend it here, it will probably become a circle. So these are circles which are imaginary in nature. This is the path which I am taking. This is the path which I am taking. These circles, they are said to be instantaneous. Instantaneous circles. The particle goes in a random curved path. It is a part of different circles at different times. So can I say any curved motion is a combination, is basically a combination of small arcs of instantaneous circles. Small arcs of instantaneous circles. Small arc here, here, here. So like that there are many such arcs. I hope you agree with this statement, everyone. Okay, I hope you agree with this statement. This is a small arc here, a small arc here, a small arc here, a small arc over here. So all these small arcs. Each of these circles will have their own individual centers and also something called as the radius. This center is also called as the center of the curvature. Center of the curvature, and this R is called as the radius of the curve or the radius of the curvature. How sharp that curve is decided by the radius. If the radius is small, it is going to turn really quick. If the radius is very large, it's going to change the direction very slowly. So the radius decides how much curviness is there in that particular path. Is that making sense? So in a way, every curved motion is actually a circular motion of small arcs being combined together to make up that path. Those small arcs are a part of some imaginary circle. the circles could be different or same. They themselves have their own centers and their radius, called as the center or the radius of curvatures. I hope till this point everything is clear. At any point of time, you will see that the velocity at that instant, the velocity is basically tangent to the path, is tangent to basically the path which is being taken. It's always tangent at that particular point. If you draw a tangent, you will see that the velocity will always be tangent at that particular point. I hope this is clear. Great. Now, since you have understood it till here that, okay, what circular motion is, not a narrow definition, rather it's a very broad definition. So many examples are there of now circular motion, because any curved path is at the end of the day a part of a circular motion. Now, whenever things go around in a circle, to locate where it is, what is it doing, how things are happening, basically the kinematics part, we generally use a system where you tell me what is the angle-wise position, what is the angle-wise velocity, what is the angle-wise acceleration, rather than just velocity, displacement and acceleration. I'll tell you why. If something is going like this, the velocity is changing the direction. It's not constant, it is continuously changing direction. It might be even accelerating, continuously changing the magnitude and direction. Even the positions are changing. Here the coordinates could be different. Here the coordinates are different. Here the coordinates are different. So coordinates are continuously changing. So it is easy to understand in angular terms rather than in meters or XY coordinate terms. Getting my point? So usually we specify, listen, the particle is at 0 degree or the particle is at 30 degree. It is at 60 degree, 5 meters away from me. 20 meters, 70 degrees from me. So if I know, oh, it is 70 meters from me at 20 degrees, I know, okay, this is 20 degrees, 70 meters, okay, it is here. So you can locate the particle which is going in a circular way in a much easier manner. So what we do is basically we need to have something called as our reference line, We also have our origin. This is our origin. And we mention the position of the particle in circular terms, something like this. Okay, listen, the particle is at a distance r, making an angle theta. So this is the position of the particle. Maybe that particle was actually going in a circular path like this. So as the particle rotates, theta will change, r will also change. This origin can be also taken down as the center. Origin can be also taken down as the center. Okay, so it's very easy to locate the position of the particle. Hence this theta is called as the angular position. What is it called? It is called as the angular position. Unit is either in degree or in radian. Degree or radian, any one of them, but usually we use this than degree. That is what you should understand. Is this point absolutely clear till this point? Give me a thumbs up, then we'll go ahead. What is the meaning of angular position? Now if this particular angular position changes, and which will happen, we know that. So after some time, maybe the particle has reached here. So this could be the initial angular position. This could be the final angular position. From here to here, it took some time and it reached here. So this angle which it has covered is called delta theta. That is basically called as your angular displacement. This angular displacement delta theta is nothing but final minus initial angular positions. So it is nothing but change in the position. So final minus initial, as simple as that. Okay, so that is your delta theta. I hope it is absolutely clear till this point what angular displacement is. Now, just to give an example of angular displacements, say for example, a particle completes one revolution. A particle completes half a revolution. Can you tell me what are the angular displacements in each of these situations? See, if you talk about just displacement, displacement will be the diameter. The displacement will be the diameter here, which is basically 2 times of r. Here, it has come back to the same point, so displacement will be 0. But angular displacement is something else only. Here, the angle-wise displacement, you have moved 180 degrees, basically pi radian. Here, angle-wise you have moved, don't say 0, the angle-wise displacement is 360 degree or 2 pi radian. It will be a shame if you say it is 0 degree. It will be an insult to it because it has actually rotated one circle. But imagine there is a particle which goes around once and goes around the second time and reaches here, basically 2 revolutions. Yes, the displacement, because the same point is there initially and before, displacement is 0. But if you ask me, what about the angular displacement? Well, that would be 2 pi into 2, which is basically 4 pi radian. Do you guys get it? It will be 4 pi radian. But imagine there is a particle which goes like this, here maybe, and takes a U-turn and then comes back over here. It just went like this and came back again to the same point. Yes, the displacement is still 0, but angular displacement is also 0 again. Angular displacement is also back to 0 again. Is that okay? So this is how angular displacement works. When you're rotating on one side, even if you come back to the same point, don't say it is 0. You have rotated by some amount, so that has to be counted. Okay? But when you rotate one way and again come back, then it might come back to 0 radian. Okay? That's how angular displacement works. A lot of people do not know this concept. I have seen many people saying angular displacement is 0 in this case, even 0 in this case, which is not the right answer. Okay. Now the next term which is there, is basically, okay, fine, listen. Can't I just move this? I have moved so much in some time. Let's say I was here at some time. I reached here at t plus delta t. So what I get now is a term called as angular velocity on an average. Okay. So basically what you get is omega, which is called as the angular velocity. Angular velocity is nothing but how much time you have taken, put it in the denominator, and how much angle you have displaced. Angular displacement. That's it. It's just like displacement by time. Here it is angular displacement by the time. So in this case, our average value of omega will be nothing but the angular displacement, which is delta theta upon the time taken. Our displacement was delta theta divided by basically the time taken. That will give me the average angular velocity. This quantity over here is basically average. If you ask me, what are the units of this? What are the units of it? This is radian usually. So divided by time, so this is second. So radian per second is the correct answer. Yep. Okay. I hope this is clear. Makaran, remember, NEET 25 will be difficult if you don't study. If you study, it will be easy. It's very simple. Okay? So don't search such things. YouTubers who do not intend to teach, they will make such videos at this point of time to scare students. But if you watch such videos, you will be scared or you will unnecessarily worry about things which you are not supposed to worry. Just study. That's it. Things will be easy. As simple as that. Don't waste your time on such videos. Okay. Next important thing. This was average. You also have some instantaneous terminology. So if I want instantaneous angular velocity, at that moment, what is my angle which is being covered per unit time? How much angle I am covering per unit time? Well, the answer for that will be, instead of delta, you will have d. So it will be d theta by dt. So that is basically the derivative terminology which has come into play. So it will be d theta, small angle covered in a small time. Okay, I hope this is clear. Okay, I hope everybody understood this. This is basically delta t becomes very small but not equals to 0. So therefore, d theta is a very small angular displacement. Angular displacement, as simple as that. Correct. Moving ahead to the next terminology, guys. Moving ahead to the next terminology. So imagine again, you have this reference line going over here. This is your origin or center. And let's say you were here at this point of time, and then after some time you have reached over here. Okay, you are going in a curved path. At this point of time, you had some angular velocity, I will call it omega I, instantaneous. This was your final angular velocity. You have changed your velocity. Earlier you are covering fewer radians in a second. Now you are covering more radians in a second. Fewer radians to more. Or you are covering more and then now you are covering less. So you have changed the angular velocity. So now the term that you will get is basically nothing but alpha. Is nothing but alpha, which is called as angular acceleration. Angular acceleration. Angular acceleration is nothing but how much time is taken. You put it in the denominator, and on the top you just put the change in angular velocity. So change in angular velocity is delta omega, and the time taken, if I put it as delta t, I will basically get alpha, but that is average acceleration. Mind it, it is nothing but average acceleration. Unit of this would be radian per second, so it will become radians per second square, and the instantaneous value of your alpha will be just like before. Instead of d theta by dt, what you will have is nothing but d omega by dt. That's it. So instead of a large change in a big time, you will have a small change in that small time. That is what your instantaneous value will be. This is your average. Average is usually represented by triangular brackets. Correct. So if something has 0 alpha, that means omega is not changing. If alpha is positive, usually it would mean that you are increasing the velocity. If alpha is negative, it would mean that you are decreasing your velocity. So whatever you have learned in translatory motion, linear motion, same terms are there even in rotational or circular motion. You had velocity there, here you have angular velocity. There you had displacement, here you have delta theta, angular displacement. There you had a particle accelerating in a straight line, here you have particle accelerating in a circular path. So all the things are there even in circular motion. So instead of a particle having initial velocity, now you have initial angular velocity, omega naught. Some velocity finally after some time, final angular velocity. Displacement, angular displacement. Acceleration, angular acceleration. Usually the symbol for displacement is not this. Usually it is delta theta. Yeah. So all these things are there, which means can I also write down equations of kinematics like I had in linear motion? The answer is yes. So therefore, you also have something called as the kinematics of circular motion. Kinematics of circular motion. Definitely you have this term. So if there is something having some velocity omega I, after some time it gets an angular velocity omega f, and in this particular process you have moved some angle delta theta, but while doing so you ensured that your angular acceleration is constant. Only then this is valid. Remember, kinematic equations were valid when acceleration was constant. So these equations are valid when angular acceleration is constant. So what will the equations look like? So first equation is final angular velocity will be initial angular velocity plus your alpha angular acceleration into the time taken. Then you have into time plus half alpha into t square. Similarly, final angular velocity square will be initial angular velocity square plus you will have 2 alpha and delta theta. These are your kinematic equations. These are your kinematic equations, but in circular motion. But in circular motion. So please remember them. You will be needing it for solving questions. We'll be coming to questions now in a bit. Okay? All this is done. Yep. Angular velocity, etc. Okay. Now, you will see one weird thing happening in circular motion, which is regarding the direction. See, when things were moving in straight line or curved lines, velocity was along the tangent. If a particle is going there, I know velocity is there. If a particle is increasing the speed, I know acceleration is there. I can see acceleration due to gravity is down if I drop something. I know if a particle goes from here to here, this is the displacement. But in rotation, how do you give the direction? Because I have a small problem. Imagine I tell you, hey, listen, you know, this dog was there, it was going like this. So is this clockwise or anti-clockwise? A dog went mad and it started running around like this. You'll be like, sir, it is clockwise. It is clockwise. It is going in the way a clock would move, so it is clockwise. Now, if I show my hand going exactly like that, for you guys, I hope my hand is going in the clockwise direction. But you know what? For me, it is not clockwise, it is anti-clockwise. It is anti-clockwise. Don't believe me? Just check this out. I just turned and just kept on rotating my hand. Isn't my hand rotating in the anti-clockwise direction? But if I just turn around, then it becomes clockwise. So you might be confused as to whether it is clock and anti-clock. So you will have to mention which side are you seeing it from, which further complicates the question. Number one. Number two, when we add vectors, you never have added vectors like this. This vector plus that vector is equal to this vector. You don't do such things. Instead, we do this. This vector plus this vector is this. A vector is a straight line. Vector is not curved. It has an arrow, it has a tail. It can't be like this because anybody can draw between any 2 points infinite number of curves. One person will draw it like this, one person will draw it like this, one person will draw it like this. Who is correct, who is wrong? So if you want to treat it like vectors, there has to be a better way of doing it. There has to be a better way of doing it. Imagine we tell you that, hey, listen, use your right hand. You have the 4 fingers. Make it go in such a way that it is going around the motion, around the circle in the sense of the motion. The motion is like this. Make your 4 fingers go like that. Make your 4 fingers go like that. So your curled fingers, your curled fingers are in this direction. See where your thumb is pointing? If your fingers curl like this, the thumb is pointing in the inside of the plane of the board. It's going away from you, it's going inside. So I will say that the motion is inside. You will be like, sir, what is going inside? Nothing. But it becomes very clear to understand that, okay, if the motion is inside, means you just hold your thumb towards that direction. Automatically your fingers will tell you which way it is actually going. Nothing actually moves here, but it now becomes like a vector. Because just think about it. If I tell you, hey, listen, there is a motion in this particular direction, you will be like, okay, I have to just hold my thumb in that particular way, and I see my curled fingers going like this. So immediately I understand, okay, the object is going in this particular manner. It becomes very easy to visualize it. And now this is like a vector with a straight line. We can add and play with vectors using triangle laws. So that is the reason why we use a convention called as the right hand thumb rule to make it into vectors, to apply laws of vectors, and to avoid any confusion which may arise. So that is why right hand thumb rule gives me the direction of the velocity or of the motion or any such rotating quantity. You will see this right hand thumb rule coming in torque or even in angular momentum and of course in angular velocity. So if this disc is rotating like this, all you do is take your 4 fingers, make it go around like that, the thumb will come here. So the angular velocity is in this direction. Nothing is actually coming here. It's just a representation that if you hold your thumb, the fingers will guide you to the correct direction of rotation. That's what it shows. Okay? Everyone clear? Give me a thumbs up with your right hand. Give me a thumbs up with your right hand quickly. All right. So we have done this. Let's do some questions based out of this. Let's say, for example, find omega if RPM of a fan is, let's say, 300. Okay, that's the question. Let's start with a simple one. Find omega if rounds per minute. RPM stands for basically rounds per minute. Rounds per minute is basically your RPM. Okay. Now what do we do with this? Let's see. Usually omega is given in radians per second. We know that if you complete one round is how many radians? It is nothing but 2 pi radians. Okay. So look over here. I want to find omega. RPM is 300. 300 rounds means 300 into 2 pi radians. 300 rounds is 300 into 2 pi, like that 300 times. So 300 rounds are there. But in how much time? In a minute. So you divide this with a minute. But a minute has how many seconds? 60 seconds. So 60 goes with 300 5 times. 5 into 2 is 10. So 10 pi radians per second. That is your omega. That becomes your omega. Is that clear, everyone? So that's how you convert from RPM to radians per second or radians per second into RPM. All right. Let's see if you guys can do this really quick, my dear students. Convert, 25 pi, convert 40 pi radians per second into RPM. Come on, exactly the opposite. Convert 40 pi radians per second into RPM. Do the exact opposite, guys. So 40 pi radians you have to convert per second into RPM. Think what you will do. Here you multiplied it by 2 pi and divided it by 60. Now you will do the exact opposite. You will multiply it by 60 and divide it by 2 pi. What you get now will be in RPM. 40 pi by 2 pi, it will go basically 20 times, and multiplied by 60, that will be RPM. So it is basically 1200 RPM. That is the answer. 1200 RPM. Is that understood? So when you are going from RPM to radians per second, you divide by 60, multiply by 2 pi to get that pi, because pi has associations with radians. When you don't want that pi, because you don't want radians, you divide it with 2 pi. So naturally you have to multiply it with 60. So that's how you can do this question. Let's go to the next question, guys, coming up on your screen. If the omega changes, from 2 pi radians per second to, let's say, 12 pi radians per second in 2 seconds, then angular acceleration and angular displacement is how much? That's the question. Let's try to solve this. What and all is given to us? First, let's write down. Omega changes from this to this. That means initial velocity is given to be 2 pi. Final velocity is also given to be me as 12 pi, and the time given to me is 2 seconds. Alpha is asked and delta theta is asked. There is no other choice other than to use kinematic equations. Okay, so let's start using our kinematic equations and see what do we get. Using final velocity is initial velocity plus alpha into time. Final is basically 12 pi, initial is basically 2 pi, alpha I do not know, time is basically 2. 12 pi minus 2 pi is basically 10 pi is equal to 2 alpha. Therefore, alpha will be 5 pi radians per second square. So I got the first answer, which is alpha. That is done. All right. Let's go to the second part of the question where you have to find delta theta. There are many ways you can do it. One of the ways is using the third equation, like omega final square is equal to omega initial square plus 2 alpha delta theta. This is one way. Or you can use S is ut plus half at square also. Or you can also use basically delta theta is equal to omega initial into t plus half alpha into t square. Anyone will give the same answer. Let's say I use this. Initial velocity 2 pi, time 2 seconds plus half. Alpha we just found out to be 5 pi. Time 2, so 2 square. So this will become 4 pi plus 2 square is 4, 4 by 2 is 2, 2 into 5 is 10, so 10 pi. So this will basically become 14 pi radians. That is the displacement. If you talk in revolutions, you can say 14 pi by 2 pi, which is 7 revolutions. Because each revolution is 2 pi radian. So if I divide by 2 pi, I get how many rounds it is doing. Check the option if it is in radian or in rounds. Accordingly, you decide how you want to calculate. Always, obviously, you'll check the options. What are the units? Let's go to the next question, my dear students. Here it comes. All right, get ready for it. Say for example, the next question says, a particle in circular motion starts to retard from 300 RPM to 120 RPM and takes 5 rounds to do so. Question is, find alpha and the time taken. Find the angular retardation as well as the time which it has taken. First come first, I don't like RPMs, you should convert it into SI units, which is radian per second. So let's do that first. So initial velocity 300 rounds per minute multiplied by 2 pi divided by 60. So 60 goes with 35 times, so 50. So it will be basically 100 pi radians per second. Okay, 100 pi radians, oh sorry, not 100 pi, my bad, 10 pi. 10 is already taken. 10 pi radians per second. Next, final velocity is nothing but 120 RPM. So multiplied by 2 pi divided by 60. So this goes 2 times. So this will just become 4 pi radians per second. Now, I don't know the time. I don't know alpha. I have to figure them out. But one thing is given, that is how much has it moved, delta theta. And that is given to be 5 rounds. Each round is 2 pi radians. So this will be basically 10 pi radians. So this will be basically 10 pi radians is the angular displacement. The best way to solve the problem, I feel now, is to solve for alpha first using the third kinematic equation. So final velocity square is initial square plus 2 alpha into delta theta. Finally, the speed is basically 4 pi. So 4 pi square. Initially the speed is 10 pi. So 10 pi square plus 2 into alpha I do not know, but displacement is 10 pi. So 4 pi square is 16 pi square. This goes on this side, will become minus 100 pi square. Okay. This will become 2 into 10, which is 20 pi alpha. So pi cancels everywhere. Okay. If you want, I'll just show it to you right over here. Okay. Pi, one of this pi and pi has gone. Okay. So let's see what do we get now. So 100 minus 16 is 84. So I'll get minus 84 is equal to basically 20, and this pi is there, alpha. So therefore, our alpha is 84 divided by 2 is 42. So minus 42 pi radians per second. Just check this out. Minus 42 pi radians per second. Everybody with me on this? Yep. Everyone clear till this point? How we did this? We have used the third kinematic equation. Great. Now once this is done, the next step of the problem is to find the time taken. I think for that this will be useful. Omega final is omega initial plus alpha into t. Final value is nothing but 4 pi. 4 pi. Initial value is basically 10 pi. Alpha is negative because it is retarding. So minus 42 pi multiplied by the time. Bring this guy over here. So 42. So 42 pi t will be 10 pi minus 4 pi, which is basically 6 pi. Pi goes. So time will be basically 6 divided by 42. Is that right, everyone? 6 divided by 42, which is nothing but 1 by 7th of a second. Which is nothing but 1 by 7 of a second. Everyone? Clear till this point? Understood how to solve these questions? Great. So, yep, 1 by 7. 1 by 7, not 7 seconds. Yes, be careful. I think you guys made a silly mistake. You forgot that 42 was on the top and it goes down below. So 1 by 7th. So very quick. So this is how you basically use these kinematic equations which I just gave it to you over here. Okay, this is the simple application of kinematic equations. Let's do one more question, guys. Let's do one more killer question. All of you get ready. a motor rotating at 20 pi radians per second reverses its direction in 10 seconds. Find alpha. Find alpha. Also, the time when it stops for a moment. Time when it stops for a moment. That is the question. Let's see if you guys can do this. Then we'll go ahead. All right, ready for this? Let's see. A motor is going at 20 pi radians per second. So omega initial is basically 20 pi. Finally, you might think, what is the speed? You'll be like, sir, it is 20 pi only. That is wrong. It should be minus 20 pi. Why? Because it is clearly mentioned in the question. It reverses its direction and it takes 10 seconds for it. So it was going clockwise maybe, and it stops and then it goes anti-clockwise. I hope this is clear. Everyone? Yeah. Oh, it was 4.2 pi. I forgot that 0. I'm so sorry. I think I forgot that 0 over there. Yes, this should be 4.2 pi. And same thing over here too. So this should be 4.2. My bad. 4.2. So decimal means 1 by 10. So this will be into 10. So this will be 10 by 7 seconds. My bad. 10 by 7 seconds. Sorry, I forgot the decimal in the previous question. That 0 was also there. So I put 4.2. So negative 4.2 radian per second. And I corrected the final values also. I made this 4.2. 4.2 is 42 by 10. So 10 goes on the top. So 10 by 7. Is that okay now? Fair enough, guys? Cool? All right. Great. Yes. So let's solve this particular question now. Let's see how do we do this. In order to find that alpha, I think we can use first equation itself. So final is initial plus alpha into time. Final is minus 20 pi. Okay. Initial is 20 pi. Alpha, do not know. Time, 10. So basically alpha into, or rather 10 alpha will be, take this on that side, it will become minus 20 pi, which is basically minus 40 pi. Okay, so basically alpha will be minus 4 pi radians per second square. That is what it is. So alpha will be minus 4 pi radians per second square. Okay, now that we have got alpha, the next step of the problem will be to find the time when it stops. So again we can use this equation only. When it stops, final will be 0. Final will be 0. Initial will be 20 pi. Alpha will be negative. So negative 4 pi. Into time. Time I do not know. So therefore, solving this equation, bring 4 pi t here is equal to 20 pi. So 4 pi goes with 20 pi 5 times. So answer is 5 seconds. So within 5 seconds it stops. Again it reverses and accelerates and increases the speed. Cool? Very nice. Let's move to the next question on your screen. If the angular position is given by theta is equal to t cube radians, find number 1, omega alpha as functions of time. Number 2, instantaneous angular velocity at 2 seconds and alpha at 2 seconds. This is at t is equal to 2. Instantaneous angular velocity and instantaneous angular acceleration at 2 seconds. The third one is average angular velocity and average angular acceleration till 2 seconds. They are two different things. Average versus instantaneous, guys. Okay, let's solve this problem one by one. First, let's solve this for omega and alpha. Theta is given as TQ. You might be wondering what to do. Don't get scared. I just told you just some time back that omega is derivative of theta and alpha is derivative of omega. So this should be just like how we performed operations on translational motion. From position you find velocity, from velocity you find acceleration by derivative. Yes. So just do that. Nothing great. So let's go down and see. Yep. Okay. So omega will be just the derivative of theta with respect to time. So derivative of t cube, which is 3t square radians per second. If you ask me what alpha is, alpha will be nothing but d omega by dt. So take this, take just the derivative of t square. So derivative of t square is 2t, which means it will be 60 radians per second square. Now let's do one small thing over here at this point of time. Omega, let's find omega naught. That means initial velocity. Initial velocity will be how much? It will be put time as 0. So it will be 0 radians per second. Then also let's find angular velocity at 2 seconds because that is what is asked. So put time as 2. So put the time as 2. So you will get that as 2 square is 4, 4 3 is 12. So 12 radians per second. Similarly, do the same thing over here. Find angular acceleration at 0 seconds. Just keep it on the sidelines. I know it is not asked, but just solving it. So it will be 0 radians per second square. If you find angular acceleration at 2 seconds, 2 6 are 12. So coincidentally, that is also 12 radians per second square. So this is done, this is done, this is done, this is also done. So first two problems are done. Now the question is to find the average part from 0 to 2, 0 to 2. Let's go by the definition. What is average angular velocity? It is delta theta by delta t, change in the position by time, which means position at 2 seconds minus position at 0 seconds divided by the time. Oh, so average velocity will need these two values which I have not yet found, which we can find out, not a big deal. So think, how much will theta be at 0 seconds? It will be 0 radians. How much will theta be at 2 seconds? 2 cube is 8, so it will be 8 radians. So just substitute that over here. Final theta is 8, initial theta is 0, time taken is 2. Therefore, average value of omega is 4 radians per second. So average is basically 4. Instantaneous was 12 at 2 seconds. Is that making sense? Similarly, alpha is the change of average alpha. This is average alpha is the change of angular velocity upon time. That means final minus initial by the time taken. Therefore, this would be final velocity angular wise is 12. Initial is 0. Time taken 2. So it will be 6 radians per second square. That is your average acceleration. So this is also done now. So from one Chintu Mintu small equation, we can find so many things. We can find so many things. That's what you can see. Clear, my dear students? Okay. And you can see the similarity in linear motion versus circular motion. So that's why they say in physics, especially the 11th standard portion, whether you're a dropper at 12th or 11th, the 11th standard portion is very important because you understand these things, you can understand most of the things. So remember, in the entire of physics, it's always the mechanics and the electromagnetism, which are the most conceptually demanding chapters and the most important must do things before doing anything. It's not ray optics, it's not modern physics, it's not thermal, it's not fluids, or it's not waves. If you get these things right, mechanics and electromagnetism, everything else you can understand, build that concept. All right. Now that we have solved these questions, let's go to the next part, which is the relationship between the linear terms versus the angular terms. And it is not that difficult to see what it should be. Say for example, there is a particle and it is going in a curved path. This is the length of the arc which it covered. Maybe it had some radius. This was a part of a circle. This was some radius. It covered some angle. Let's say that angle which it covered was theta. We all know in trigonometry, we have studied this. The length of that particular arc is going to be nothing but the radius into theta. Now I got a very interesting idea. Why not derivate on both sides? So the length of the arc divided by the time is equal to, radius is a constant, so keep it outside, is equal to r d theta by dt. You know what d theta by dt is? How much angle you covered per unit time? That is nothing but omega. The length which you are covering per unit time, that will give me basically the velocity which you have gone with per unit time. So this is just velocity per unit time. So that's how I get velocity is r omega. This velocity is the tangential velocity, and velocity is always tangential only, because when you are going in a circular path, no matter how that circular path is, at every instant the velocity will be along the tangent drawn. So that is the reason why it is also called as tangential velocity. Okay, it is always along the tangent which is drawn. So that's why tangential velocity. Tangent which is drawn, so tangential velocity. I hope this is clear, everyone. So V is equal to R into omega. The next important result comes is if you differentiate this velocity with respect to time. If you differentiate this velocity with respect to time. So V was R omega. If you differentiate again this with respect to time, you will get d omega by dt. D omega by dt, we know what this is. What is this, guys? D omega by dt. Rate of change of angular velocity. What is it? Yes, it is angular acceleration. But then what will be there on the right hand side? Don't worry. See, if you are going in a curved path and let's say you are here and then after some time you are here, the velocity has changed. So in a small time interval, the velocity has changed. So this was initial, this was final. So that change in velocity per unit time, what you get is a new term over here that is again along the tangent. So that is called as tangential acceleration. Tangential acceleration, it is the acceleration along that path. So you get this AT, tangential acceleration. This tangential acceleration is responsible for the change in speed. Very, very important. I will show you 3 cases. Just take these 3 cases. Here, I tell you, listen, the tangential acceleration is 0. Then what would happen is that if the velocity was 5 meters per second, even after reaching here, the speed would still be 5 meters per second. Direction can change, but magnitude will not change. But let's say a particle had a speed of 5 meters per second here, and maybe the tangential acceleration is basically some positive value. So you will see after reaching somewhere here, it will have a new speed, maybe 9 meters per second. So tangential acceleration is responsible for the change in speed. Similarly, imagine particle again having 5 meters per second here, but this time I tell you, hey listen, the tangential acceleration is negative value. So maybe by the time it reaches here, the speed could have come down to 2 meters per second. So it changes the speed of the particle. It does not affect the direction in any way. Is that okay? Is that understood? What is the meaning of tangential acceleration and tangential velocity? Clear till this point? Can we go ahead, my dear students? Yep, can we go ahead? What is the meaning of tangential velocity and obviously tangential acceleration? But then I have a simple concern. Okay, sir, you just told that if you are going in a curved path, tangential acceleration is the one which is responsible. Tangential acceleration is the one which is responsible for changing the velocity's magnitude, meaning the speed. But if it is turning, it is changing the direction. And remember, any velocity is a vector quantity. Velocity is a vector quantity. So it has both magnitude, meaning v bar's modulus, as well as it has some direction. So you are saying that the magnitude is affected by the tangential acceleration. So there must be somebody to affect only the direction. Somebody to affect the direction, just like this tangential acceleration affects magnitude, somebody to affect the direction. So who is that? That person is exactly perpendicular to this. Exactly perpendicular to this. And if you remember correctly, just some time back I had told you, any curved path is a part of many arcs made up of many instantaneous circles. If you remember this concept. So let me just show a random circle. Oops, over here, maybe. It's a part of a instantaneous circle, right? This is your instantaneous circle having its own instantaneous center of curvature. So what you get now is the next acceleration which is going to pass through the center. This is called centripetal acceleration. This is called the centripetal because it is passing through the center. This affects the direction. This affects the magnitude because it is acceleration passing through the center. If you combine both of them together, what you get is the net acceleration. This is your net acceleration. And this acceleration is the vector sum. This acceleration is just simply the vector sum of centripetal as well as tangential. Magnitude wise, it is just AC square plus AT square. This is what centripetal, tangential and total accelerations actually are. Is that clear? And this should be very this is very important. You should remember this. You should understand why this is happening. This acceleration along the tangent can change the length. So that's why it affects the magnitude. This is perpendicular to it, passing through the instantaneous circle center. That's why labeled centripetal. And because it is perpendicular, it can turn it. It's like the steering wheel. You turn it, so centripetal acceleration will come. You turn it this way, centripetal acceleration will go that way. So can you also guess this now, that by the time maybe somebody will reach somewhere over here, then the tangential will be here, centripetal will be here, and the total will be, the vector sum of them. So this would be the tangential, this would be the centripetal. Is this clear how centripetal and tangential works, everyone? And what does it do? What is it responsible for? Yep. Okay. Now, there is the magnitude of the centripetal acceleration. Okay, I've put all the formulas, definitions right over here. What is centripetal? What is tangential? It is responsible for changing the direction, that is centripetal. Tangential is responsible for changing the speed, and total acceleration is the vector sum of it. Now, what is the magnitude of centripetal acceleration? The value of the centripetal acceleration is, the value of the centripetal acceleration is. You remember the tangential speed? So velocity square divided by the radius, or you can also use angular speed square multiplied by r. It's one and the same thing, because if you somebody puts velocity as omega r, square it divided by r, so it will become omega square r square divided by r will cancel, and you will be just left with omega square into r. So centripetal acceleration's formula itself is v square by r or omega square r, one and the same thing. Everyone, it always is directed towards the center, perpendicular to the circle's tangent. Keep this in mind. This is a very, very important formula. If you ask me what is the formula for tangential acceleration, I will say, because it only changes the speed, it is a d derivative of the velocity with respect to time, but not velocity, magnitude of the velocity, because we are talking about speed. Speed means the magnitude of the velocity. Speed means the magnitude of velocity. Very, very important. So tangential acceleration is just the rate of change of speed, not rate of change of velocity. But your total acceleration which is there, that is dv bar by dt. That is your rate of change of the velocity. The complete rate of change of your velocity is your total net acceleration. Just the speed change, tangential, the direction change associated with centripetal. Very important formulas. Keep this in mind. Just to give you some examples now. Imagine somebody tells there is a particle which is going in a curved path, and at any instant the velocity is given by t square meters per second. T square meters per second. First, the question is to find, and let's say at that particular instant the radius is given to be 10 or 0.1 meter, example. First question is find the tangential acceleration and centripetal acceleration at t is equal to 3 seconds. Number 2, find the total acceleration at t is equal to 3 seconds. These are the questions. Let's try to solve them. Okay, let's try to solve them. Because velocity is already given as t square, this is the magnitude of the velocity. Remember, it is v bar's modulus, which itself is v, is given to be t cube. I can immediately find tangential acceleration, which by definition is the rate of change of speed, which means it is the rate of change of t cube in this case. Sorry, t square, my bad. T square in this case. So t square's derivative is nothing but 2t. But you have to find the tangential acceleration at basically 3 seconds. So 2 into 3, which is basically 6 meters per second square. 6 meters per second square is the answer for tangential acceleration. For centripetal acceleration, what I will do, the formula which I will use is v square by r. That will be easier. Velocity is basically t square. Square that divided by the radius, which is basically 0.1. 0.1 means 10 on the top. T square, so it will become t raised to 4. So centripetal acceleration at 3 seconds will be 10 into 3 raised to 4. 3 square 9, 9 into 3 27, 27 into 3 81. So it will become 810 meters per second square. That is your centripetal acceleration. Everyone with me on this? Great. Last part of the question says find the total acceleration. So it will be root of the centripetal square plus the tangential square. So it will be root of 6 square plus 810 square. So you can do this math. Maybe I'll do it on a calculator or something, but you don't do that. So this will come out to be 810 square plus 6 square, which is 6,56,136, the whole thing under the root. So that's around 810.02 meters per second square. It will be almost same as 810 because this value is very small in front of this. So we knew that it will come close, but it will be slightly more. So how much more? It's 0.022. That's all. Okay, roughly the same. Everyone till this point absolutely clear how we can find out tangential, centripetal and the total accelerations? Let's do one more interesting question, which is very, very nice. Imagine this is your projectile motion now, where this is projectile motion. You throw a mass at certain speed, let's say u, making an angle theta. It reaches the maximum height also. Let's say I call this point O, let's say I call this point H. At both these points, basically at O and H, find number 1 centripetal and tangential accelerations, number 2 radius of curvature. Radius of the curvature. That is the question. It's an amazing question. Let's try to solve this, guys. Okay, read the question again and again. At this point and this point, find centripetal and find the tangential. Number 1. Number 2, find the radius of curvature. See, if you look at the beginning, okay, if you look at the beginning versus on the top, let me get rid of this diagram. I won't need it much now. At the beginning, it's a part of a circle. So just show a circle. It's probably like this. This is U. This is the ground level. And of course, it's a part of a circle. So I'll just show the radius. So this is basically the radius in the first step, in the first part when it has just started its journey from the ground, or radius at O, I can call it, radius at O. When it reaches the top, again it will be a part of a different circle. Here the path was this one. Oops. Here it was going like this. Once it reaches the top, the velocity will be horizontal, mind it. The velocity will be horizontal like this. And this would be that radius of curvature. This is the radius of curvature at height h. What do you think will be the speed at the topmost point? What would the speed be at the topmost point? Remember, anything going in a projectile motion at the topmost point, the speed is u cos theta. So just substitute the speed as u cos theta. That is what it is. Correct? This is at point h, which is at the topmost point. Okay, now what? Any projectile motion obviously accelerates due to gravity, and the acceleration due to gravity is basically always going to be downwards. So g is the total acceleration. G is the total acceleration. So let me just show the net acceleration like this. This is basically your net acceleration. Your net acceleration is basically like this. I'll just show it like that. Now, any acceleration will have two components, just like I've shown over here. Any acceleration will have two components. One, along the velocity, which is tangential. Second is perpendicular to the velocity, which is called centripetal. It passes through the center. So split that acceleration into two components. I think I'll get those two components like this. This is the tangent. This is the tangent. So when I split it, I'll get two components like this. Correct? This is down. So there will be two components. One component will be like this and the other component will be like this. This is centripetal. This is tangential. Do the same thing over here. This is the velocity. Already G is perpendicular. So I think G itself will be the centripetal acceleration. There will be no component here. So the tangential will be a big fat 0. Did you get it? I don't even have to split the G vector because it is already perpendicular to the velocity. So this must be the centripetal. There will be no component only along the tangent. Till this point, is it clear? Thank you guys for all the warm firing up in the chat box. Thank you Atluru, Satyashri, Madhumati, Harish, Krishna. Thank you so much Atluru. Thank you. So, I already found the answer for height h. Don't think, sir, this acceleration which you told over here, right? I thought it was something crazy. It's nothing but your usual acceleration which you have been using all this while. Normal acceleration, that's it. It has two components, one along the velocity, one perpendicular to the velocity. One is called centripetal, one is called tangential, one changes the speed, one changes the direction. That's all. So now, what we have come down to is that, okay, this part is done. What about this? Don't worry, I at least know the angle over here. So if this is theta, this will be 90 minus theta. Again, this will be theta, and again this will be 90 minus theta, and again this will be theta, and it continues. If you remember our division of 8 parts, so if you divide it into 8 parts, again this will be 90 minus theta, and again this will be theta. Okay, so that will continue. But let's not go there. If this is G, centripetal must be how much, guys? It is closer to theta, so it must be G cos theta. This component is far from theta, so this is basically G sin theta. G sin theta. So we found out tangential, centripetal, centripetal, tangential, which was basically the first part. Done and dusted. Everyone fine till this point? Can we go ahead? Everybody clear? Cool? Great, great. Till this point, everybody is clear. Very nice. Now, what to do? Now, next, what to do? You have to find the radius. No issues with that. We know the centripetal acceleration's formula. What was it? I just gave you. V square by R. V square by R. So just use that. Over here, if I say centripetal acceleration is velocity at point O square divided by radius at point O. Centripetal being G cos theta, velocity being just U divided by R. So RO will be U square by G, okay, cos theta. So that is the radius of curvature of this circle at this point. Here, if you try to find the same thing, again, the centripetal acceleration will be velocity at that point h square divided by radius of curvature at h. So centripetal acceleration itself is g, velocity is u cos theta square and then RH. So radius of curvature at h will be u square cos square theta divided by g. That is the answer. So we found that as well. So this part also done. So this is how you can solve the problems of radius of curvature or just finding centripetal or tangential accelerations in any given question. Cool? Everyone till this point? Shall we do some questions based on this? Let's do. More questions, guys, coming up on your screen. Get ready for it. If a particle in circular path of 0.1 meters starts at rest having a tangential acceleration of pi meters per second square. Find number 1, angular acceleration. Number 2, centripetal acceleration at t is equal to 2 seconds. Number 3, velocity and omega at t is equal to 2 seconds. Number 4, the total acceleration at t is equal to 2 seconds. These are the questions. Let's try to solve this. Okay. Read the question again. Particle goes in a circular path, radius is given. Starting from rest, having a tangential acceleration of pi. Okay. Now let's see. Who are those people who are not liking chumma voting? This is what happens in the country. Chumma voting, but not voting rightly. Come on guys, quickly smash the like button. Yeah. Like button has to be smashed. Even if you are watching it recorded. Means a lot guys. I mean, really, how can you just watch a big class and just sit there learning everything without liking? Imagine you become a doctor and patients just, tell me doctor, okay, prescription, okay, this, okay. Doesn't even say thank you, just walks out. How will you feel? Same karma will come back then. Okay, let's find alpha. I think we can find alpha very easily. Remember, there is a formula, tangential acceleration is alpha into r. If you forgot about it, let me go back and show it to you. A tangential is alpha into r. We just did this. A is alpha r. V is r omega. We just did that some time back. And therefore, using that, alpha, I do not know. I have to find. Tangential is basically pi. Radius is basically 0.1. Therefore, alpha will be 0.1 is 1 by 10. 10 into pi will make it 10 pi radians per second square. Okay. So this part is done. Let's go to centripetal at 2 seconds. Everything is at 2 seconds. So maybe we will use some kind of kinematic equations. Without that, we won't be able to proceed ahead. Okay. So using omega final is omega initial plus alpha into t. At 2 seconds, the final velocity will be initial speed 0, alpha 10 pi, time time is how much? 2 seconds, so 2. Therefore, the angular velocity at 2 seconds will be 20 pi radians per second. So this part is done. We aimed for this, we reached somewhere, no issues. Velocity is omega into r. So 20 pi into radius being 0.1. So it will make it 2 pi meters per second. That is your velocity. So this part is done. How about centripetal acceleration? No issues. Centripetal acceleration is omega square r or v square r, anything which you want to use. Omega square into r, omega is 20 pi. So 20 pi whole square multiplied by radius, which is 0.1. So it will become 400 pi square multiplied by 0.1. So centripetal acceleration, 0.1 into 400 will make it 40. So 40 pi square meters per second square. That is the answer. Just check this out, everybody with me on this. Clear? Centripetal is this much. Now let's go to the total acceleration. Total acceleration is basically so this part was done, right? Yep. Total acceleration will be the combination of centripetal and tangential. Centripetal itself is 40 pi square, square it. Tangential is just pi, so pi square. This is negligible in front of this, guys. This is negligible in front of this, so that's why it will be just 40 pi square. 40 pi square will be the total acceleration, because this is very small in comparison with this. Make sense? Clear? Can we go ahead? Awesome. Let's go ahead to the next question. So this was also done. If alpha is equal to 3 radians per second square, omega, actually minus 3, omega is equal to 12 radians per second. In 1 second, find velocity, tangential acceleration, centripetal acceleration, and total acceleration. Okay, after 1 second. That is the question. Let's try to solve this. After 1 second, find velocity, tangential acceleration, centripetal acceleration, and the total acceleration. So alpha is given to be -3, that means it is retarding. Omega is 12. So after 1 second, let's find out the final value of omega using this kinematic equation. Let's see what happens later on. Initial velocity 12, alpha -3, time 1. So this will be 9 radians per second. But I don't want that, I want velocity. Oh, I think radius needs to be given. So radius is, let's say, 2 meters. Radius is, let's say, 2 meters. So from this, if I use V is equal to R omega, radius is 2, omega is basically 9. So therefore, the velocity will be nothing but 18 meters per second. Just check this out. Velocity comes out to be 18 meters per second. Omega has not yet come down to 0. It is retarding, but in 1 second, it has just come down to 9. So velocity, I figured it out. What about tangential and centripetal? Tangential acceleration is alpha r. Alpha is -3. R is basically 2. So it is basically -6 meters per second square. The reason why it is negative is because it is opposite to the velocity. That's why negative. It is retarding. Next, centripetal. It is V square divided by R, or just use omega square into R. Anything that you like. Omega was 9. So 9 square. Radius is basically 2. 9 square is 81. 81 into 2. 8 2s are 16. So 160. 1 2s are 2. So 162 meters per second square. That is your centripetal acceleration. Obviously, the total acceleration, when I find it out also, 162 square plus 6 square is negligible. 6 is very negligible. So it will be 162 point something. So it will still be 162 meters per second square approximately. Got it? So this is how you can solve these questions based on circular motion, which involves tangential, centripetal, total accelerations, as well as the angular components. Now, this was mainly the kinematics part. This was mainly the kinematics part. Now, the special part of circular motion, like I said before also, is something called as uniform circular motion. Uniform circular motion, where things are moving in a uniform manner, means in uniform circular motion, the thing which remains constant is basically omega. Omega is basically constant. That is equal angles per unit time. You might be wondering, isn't velocity also going to be constant? Well, actually, only the magnitude of velocity is constant, but velocity changes since the direction changes. The direction of the velocity will change. Velocity is a vector quantity, so velocity keeps changing. Keep that in mind. There are many examples of uniform circular motion, like the hands of the clock, or the planetary motions, rotation. They are happening uniformly. It's not like suddenly increasing and decreasing the speed. If you ask me about the acceleration tangentially, the tangential acceleration will be 0 since the speed is constant. The speed doesn't change. The speed doesn't change, and we saw that right over here. Magnitude is constant, but direction is changing. Centripetal acceleration is v square by r, 100% not equal to 0. So the total acceleration is just the centripetal acceleration. So you will see that the total acceleration will be directed always towards the center. So centripetal acceleration. So the magnitude of it is constant, direction also keeps changing for centripetal, you can see that. So that is how it works. So magnitude wise constant. The magnitude is constant, but direction keeps changing. The direction is obviously changing. The direction is basically changing. Keep that in mind. Till this point, everybody clear? What is the basis of uniform circular motion? What is happening in a uniform circular motion? Now, some more things about uniform circular motion. The time it takes to complete one revolution, time to complete around that circular path is called as the time period. It is called as the time period. This time period is also 1 by f, where f happens to be the frequency, how quickly it moves. The unit of frequency is basically hertz. If I say the frequency is 10 hertz, means it completes 10 rounds in 1 second. How much rounds per unit time? So that is hertz. So if it completes 10 rounds, so 1 by 10 is time period. So the time period is 0.1 second. Makes sense. 0.1 second, 0.1 second, 0.1 second, 10 times. In 1 second, it will do 10 rounds. So that is your frequency. How many rounds per unit time? Frequency is the number of revolutions per unit time. Per unit time. Another thing which comes useful is omega, which is in one round how much angle you covered upon how much time you took for that round. If you divide them, what do you get? Think about it. The angle which you cover in one round is 2 pi. The time taken for one round is basically called the time period. But wait a minute, 1 by t will be f. So it will also be 2 pi into f. So omega for a circular motion is 2 pi by t or also 2 pi f. One and the same thing. 2 pi t or 2 pi by f. Okay? Alright, Atluru, it may go on for more 1.5 hours till around 2 o'clock. So these are some important parameters specifically for circular motion. Specifically for circular motion. Let's take an example for this. Imagine a particle is going in a uniform circular motion. The radius is given to be 5 meters and the frequency is given to be 20 hertz. Question is to find number 1, the time period, number 2, angular speed, number 3, the velocity, number 4, the total acceleration. These are the things that you have to find out. Let's try this question. Not that difficult. Frequency is given, finding time period, straightforward. Time period is 1 by f. So it will be 1 by 20 guys? Correct? So it will be basically 0.05 seconds. So it takes hardly this much time to complete one revolution. So in a second it completes 20 such revolutions. Let's go to the next part. Omega. Omega is 2 pi into f, or 2 pi by time period. I think using frequency will be better here. Frequency is 20. So it does 40 pi radians per second. If it was asked in RPM, you will divide it by 2 pi and multiply by 60. So that is omega. So this is also done. What about velocity? Velocity is r omega. Constant velocity, constant speed, sorry. Radius is 5. Omega is 40 pi. 5 fours are 20 and one more 0. So 200 pi meters per second is the velocity. Let's go to the final part, which is basically nothing but your acceleration. Now acceleration is just the centripetal value, which is omega square into r. Omega, where is omega? 40 pi. So 40 pi whole square, radius 5. 4 square 16, so 1600 pi into 5. 16 5s are 80, 2 more 0. So this much, 8000 pi meters per second square. That is the value of the total acceleration. Okay, so that's how you solve these questions based on uniform circular motion. Some question they will give you this, they'll give you this, they'll ask you this. So try to do it this as homework, where instead of these data points given, you take something else. Time is given, velocity is given. How will you find other things? Or acceleration is given, time is given. How will you find frequency, etc.? Or radius is given, velocity is given. How will you find time period, this, blah, blah, blah. So try to manipulate the problem. You will get an understanding of how to use the formulas. So whenever you ask such questions, right? Sir, I understood the class, but I'm not able to solve problems. Basically, at home, you have to try these things. You have to experiment with the formulas. You have to play with the data. If this is given, that is given, that happens, this happens. Just play. You don't have to buy new books or, do something drastically different. Just this. Do that. You will get these formulas imprinted in your head. Okay. Now, the main question is, fine, sir, you just said that when a particle is going in a curved path, maybe it is a part of a multiple circles and these circles keep changing. Fine, okay. So at some instant, this is the velocity. This is the velocity. In that direction, whatever acceleration is there, you call it tangential acceleration. The acceleration in the perpendicular direction, you call it centripetal acceleration, directed towards the center. Okay. Now, the combination of these two becomes your total acceleration, which I called it as A. Okay. If there is acceleration, there must be force, 100%. Without force, there can't be acceleration. So, imagine that, whatever that total acceleration is coming out to be, like this, there must be a force responsible for that. So let's say I show that on this particular mass, there is some force which is acting, because of which it is accelerating. So as per Newton's laws of motion, that particular net force, this is your net force, combination of normal, tension, friction, spring, gravity, blah, 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 everything should be equal to mass times your total acceleration. Just like acceleration could be split into two components, the same way even that force should be able to be split into two components. One force along the center, other force providing the tangential acceleration, which is now your tangential force. So this is called as your centripetal force, which is responsible for the direction change. This is called tangential force. This tangential force, this particular tangential force is responsible for speed changes. It changes the speed of the particle. So therefore, I can easily say, using again Newton's law, Fc and Ft is equal to that particle had some mass, if you remember, it had some mass. So it will be mass times the respective accelerations. So here it will be centripetal acceleration, here it will be tangential acceleration. If you ask me, is tangential force a new force like gravity normal? I will say no. In fact, it is not, because they are just the components of the net force. You have a net force, you just take two components of it, you get these things. So, very important note, Fc and Ft are not new kinds of force like spring, etc. They are just the components. They are just the components of net force, nothing else. They are just the components of the net force. Similarly, just like previously, total acceleration was written down as centripetal and tangential's combination. Same way over here also, I can write it down as total force is centripetal force plus the tangential force. Magnitude wise, it is Fc square plus Ft square. Nothing great. Okay, this still will work. It has to work. It is the combination of these two. So, just to give an example, imagine there is a particle which is going in a circular path. Maybe mg is acting like this, maybe friction is acting like this, maybe normal is acting like this, okay? And you split these forces and just imagine a hypothetical circle over here, with center and the radius and everything, okay, like this. Then you will notice that I can split these forces into multiple components, but friction is already along the tangent, normal is already along the radius, mg will have two components, one here and one here. So if I mark the angles, let's say I put it as theta, and I show the accelerations part, say centripetal will obviously be like this, tangential, let's say, is like this, tangent along the tangent only, centripetal along the center only. If I now apply Newton's laws, how will it look? Observe carefully. I'm just going to apply net force is mass into acceleration. First along the tangent, then let's apply it along the center. That's all. That's the only change. What are the different forces? What is the equation going to look like? Observe carefully. Along the tangent, friction is there. mg's sine component is there. Can you see that? Mg will have, this particular mg will have two components. One will be mg cos theta, because this is theta, and this will be nothing but mg sine theta. Together, these two forces gives this acceleration. So can I say F plus mg sine theta is equal to mass times your tangential acceleration? Mass times your tangential acceleration. Same way, along the center, mg's cos is in the direction of acceleration, so I will take this as positive value. So can I say mg cos theta towards the acceleration? Normal is away from it, so minus normal is mass times the centripetal acceleration. This is how you use your Newton's laws of equation. It's not very different from what you did in Newton's laws. It's the same thing. It's just that you have given new names to the components of acceleration. Sometimes tangential is not there. Sometimes centripetal is not there, then it will not be even going in a circle. But it's just applying Newton's laws in two dimensions. One along the normal and one is along the tangent. That's it. If you ask me who is the centripetal force here, who is the tangential force here, please remember this entire thing, this force plus mg sine theta is your tangential force. This entire thing is your centripetal force. Nowhere in the diagram did you see me doing, centripetal force separately and tangential force like this. No, they are not new forces. In fact, they are names given to the components of the forces. So never ever show centripetal force and tangential force in the diagram. That is what you might have learnt in school. Centripetal force formula, m omega square r or mv square by r. That is wrong. Don't learn like that. Centripetal force formula is not mv square by r or m omega square r. That happens to be equal to mass into acceleration, and acceleration becomes v square by r. Hence the value comes out to be like that, but actually centripetal force is the forces component along the center. Tangential is forces component along the tangent. The value happens to be mv square by r. But centripetal force is not mv square by r. It's like saying some student got 600 marks in NEET examination. So the marks of the student is equal to 600. Student is not equal to 600. I can't say that Pandu is 600. No, marks of that Pandu is 600. So same way, centripetal force is this. The value of that happens to be mv square by r because AC is v square by r. Is that clear? Everybody with me with these examples? Okay, let's just quickly have some water. Thank you for reminding me. Okay, so I have talked about centripetal force and tangential force. Let's take a very beautiful example of that, and that is called as the conical pendulum. Now, conical pendulum is nothing but you take a string, connect it to something. Just let's forget this for a moment. Just taken my adapter. I'm sacrificing my adapter for you guys. Hopefully it doesn't get damaged. Okay, I hold it somewhere and then I give it a push like this. So it goes around like this. Can you see that? See, this is conical pendulum. But if I take it here and leave it, it goes back and forth, okay, in a single plane, meaning like this. Just goes back and forth in a vertical plane. That is a simple pendulum. That is a simple pendulum. But conical pendulum means it goes round and round. So you can see it is going round and round. So that is a conical pendulum. Are you able to understand that? Such a nice concept. See, so beautifully it is going in a horizontal circular path. So I want to find how is the angular speed, tension, etc. related in this question. So if I want to do that, obviously I start with the free body diagram, show accelerations, etc. And once I'm doing it, I also think, is this uniform circular motion or non-uniform circular motion? What do you guys think about it? Is this an example of uniform circular motion or non-uniform circular motion? Quickly think and tell me. Yes, it is a uniform circular motion because it goes with a constant speed. So let's try to do this question. Let's try to understand how this thing works. So okay, so this is conical pendulum. I'm just showing a 3D diagram in a 2D way. So forces on it, on this particular mass, this bob over here, okay, it has some mass. So there will be multiple forces on it. First will be its own weight, which will be acting downwards. So I'll just show mg like this. And on this mass, there will be obviously a tension force. The string will pull it like this. So tension obviously like this. And I can also show some angles. Let's say this is theta. So if I draw a vertical line, even this will be theta. Apart from that, I can also show that there will be a radius over here. This will be the radius, of course. This will be the radius. The length of the string would have been L, and R is opposite to theta. So clearly R is L sine theta by trigonometry. Remember, this is 90 degree. So that is the radius of the circle. That circular motion is obviously uniform circular motion. So definitely there is some angular velocity omega, and there will be centripetal and tangential accelerations which we need to figure out. Centripetal always towards the center. So that will be your centripetal. Because it is uniform circular motion, there is no tangential acceleration. That's it. That's all the equations are. Now, if you notice, the tension can be broken down into two components. One component over here, the other component right over here. This being T sine theta, this being T cos theta. In the vertical direction, y-axis, there is no acceleration only. Accelerations are in the x. So therefore, T cos theta must be balanced by mg. Therefore, T cos theta is equal to mg. Whereas in the x direction, tension sine theta is providing the acceleration. So force is T sine theta, the mass is m, acceleration is AC. The value of that acceleration is v square by r, or I can also use omega square r. So from this, r is nothing but L sine theta. R is nothing but L sine theta. Tension sine theta is as it is. Sine will get cancelled, and I will just get tension is equal to m omega square L. Okay, so this is a very important result which you should keep in mind. The tension of a conical pendulum is mass into angular speed square into the length of that wire. Use this tension over here and see what do you get. Use that over here and see what do you get. You will get m omega square L is equal to mg, L into cos theta is equal to mg. Will cancel, so I will get cos theta is equal to g divided by cos theta is equal to g divided by omega square L. This is another important formula which tells me the angle when you are rotating with some speed. So I can find the angle which it makes. I can also find the tension. And it makes sense. See, that same thing, if I rotate it at a small speed, it makes a small angle. But if I rotate it fast, do you see it makes a different angle? If I rotate it even faster, it goes with even higher angle. And as I reduce the speed, I can see the angle made is very small with the vertical. So angle depends on that particular speed. So angle depends on that speed. and tension will also change. If I rotate it fast, obviously tension will definitely go up. That's how it works. Okay, so that is conical pendulum. You should definitely know it. Another important application is about vehicle taking turns, and we will see that how the speed limit gets decided and how you can improve the speed limit when you are taking a turn. When you are riding a cycle or a bike, you might have fallen down. Hopefully you did not get too much hurt. You might have seen people falling down while taking a turn, and this happens because you skid, you slip. That means the friction is not sufficient to prevent the slipping. So the road is slippery, the tire grip is not great, or you are moving too fast. So that's why when you are negotiating a turn, meaning you are trying to adjust everything so that you do not slip, you go carefully. You make sure your speeds are well below, else you will skid, right? So which means static friction is at play here. When you are going around a curved track or a turn, even in a car, a bike, bicycle, even while walking, you make sure your speeds are not too high. Your static friction is not exceeding the maximum limit, because the moment it goes into kinetic, it will skid. So the aim is to always keep the friction in static nature. Is that making sense? That is why you have this advanced electronic control system in cars and bikes like ABS, ECS or ESC and all that, where electronic stability control or anti-lock braking skid programs and all of that, these electronics fancy jargons which you would have seen in specifications of cars and vehicles. Basically, they make sure that your vehicle speeds are regulated, the tires always are in static friction, not in kinetic friction, or else you will lose control of your vehicle. That is what they do. Yep. Now, slipping and skidding is, yes, the same thing, just different synonymous words, similar words, Krishna. Correct. So, imagine an example where there is a vehicle like this. And it is going on a curved road. It is going on a curved road. So let's say the radius of that curved road is basically R, and the vehicle speed is, let's say, V. There will be many forces acting on it. One will be basically mg will be there, then that normal force will be there, and because it is going in a curved path with constant speed, tangential acceleration is not there, but centripetal acceleration will be there. Now, if there is centripetal acceleration towards the center, obviously there must be centripetal force, but it can't be normal and mg, because normal and mg are in the vertical directions. So therefore, normal and mg just will balance each other. They will just be balancing each other. So this acceleration has to be provided by none other than friction, that too static in nature. If it goes in kinetic, it will skid. That means the vehicle is not stationary. The tires of the vehicle are not stationary with respect to the road surface contact. So therefore, it should be static and it should be in the direction of acceleration. You cannot say the friction is here and acceleration is here. Then Newton will laugh at one corner. How did you apply force in the left and how did it accelerate towards the right? If force is towards the left, acceleration towards the left. If it is accelerating towards the right, force also should be towards the right. It can't be in some different weird directions. So you will say by Newton's law, friction is m into centripetal acceleration. But centripetal acceleration, let's use v square by r formula. Now you will understand that, hey, if I increase my velocity, my friction will increase, but it can't increase beyond a limit. So there is a upper limit to the velocity. Correct? If I increase the speed, friction will increase, centripetal will increase, but friction can't increase indefinitely. There is a limiting friction. So when that limiting friction happens, this will become Fs max. This will become V max squared divided by R. Fs max is mu into N. N is mg. So N is mg. So is equal to mv max squared divided by R. Obviously this m and this m will get cancelled. Shift that R over here. That is the square of the speed. So therefore the maximum speed will be root mu rg. That is the answer. Root mu rg. If you go beyond this, your vehicle will skid. If the road is slippery, mu will be less, speed limit will be less. If you are going in a quick turn, R will be less, V max will be less. You take the turn slowly, big radius, maximum speed will increase. So that is the formula. Is this clear, everyone? Understood? Very good. Yes. Such a nice vehicle. Now, what happens is, this Pandu who is driving this vehicle, unfortunately, he goes on a road which is slippery, or his tires he does not replace. Pandu is very poor, so he does not replace the tires, so mu will become less. R you can't change, the road is same. G, you cannot change the planet. Pandu can't go to the moon and or Jupiter and say I will increase the gravity. If the tires are not good quality, then maximum speed limit will be less. So Pandu, if he drives the car on that same turn, he will skid. But we don't want Pandu to get hurt. So you have to think. So you'll be like, sir, let's buy new tires for Pandu. Okay, Pandu bought new tires, but the road is slippery during rainy season. Still Pandu will get hurt. Sir, let's not have rainy season. Well, that can't be possible. So there has to be something else which we can do. The problem is, in this setup, we are dependent on friction for this acceleration to change the direction. How about we don't depend on friction? Like, is it possible, sir? I will be like, yes. How, sir? Let's make use of normal. But then you will be like, sir, normal is in the vertical direction, acceleration is in the horizontal direction. They are perpendicular. They are perpendicular. In fact, normal was balancing mg. So how do you say normal can provide the acceleration? No worries. Let's change the road only. What do? You make the road tilted. And then our problem gets solved. Something like this. You tilt the road, that is called as a banked road. Instead of now depending on friction, you are dependent on the normal provided by the road and a component of it, which provides the acceleration towards the center. Not the complete normal, a component of it. This is like NASCAR racing, but I've seen curved tracks. These are banked roads. Now this is heavily banked. Our usual express highways are not like this, or else if a person is standing here, he will skid down because people will normally park randomly. So it is slightly turned. Even railway tracks, around the corner you would have seen it is slightly bent. Why? Why did it do that? Because you want to go around that turn without skidding. You see, a train or a bus can't do this, no? See, a biker can do this. A bike fellow can turn. Imagine a bus. Oh, the bus has to turn. Okay, everybody go towards the left side, come on, and the bus is tilting. Or the train. Imagine a train going like this on one wheel. No, not possible. So you cannot turn the train, the bus or the car. So you turn the road instead, and that's how you are able to go around it without any problems. So like you can see over here, yeah, like you can see over here, one second. The normal has a component like this, which is then n sine theta. Yes, your n cos theta is over here, which is still balancing your mg. N cos theta is still balancing your mg, but n sine theta is definitely helping me with the centripetal acceleration. Do you guys see that? It is going in a big circular path. So this is the centripetal, this is the center. I hope you are able to see it. If there is friction, then friction will also act. So we'll come to that in a bit, but definitely this is how the diagram is. With friction, what happens is, one second. With friction, apart from n sine theta and n cos theta, just like you had n sine theta and n cos theta, with friction, apart from this, if friction is also present, then this friction that you see, I hope you are able to see that friction. This friction that you see over here, that friction will also have some components. That friction will also have some components. A component of the friction will be like this, because this is theta. This will be F cos theta, and you will have again F sin theta. F cos theta and F sin theta. So if you notice over here, who is the centripetal force? Is it this or this? Neither. It's a combination of both of them. So technically, N sin theta plus F cos theta is mass into centripetal acceleration, which is m into v square by r. So all these two together is your centripetal force. Tangential is not there because it is not changing the speed. In the vertical direction, only the n cos theta will balance F sin theta as well as mg. So because there is no acceleration in the vertical direction. Is this clear how these equations come? There is no tangential force at all, only centripetal is there. After solving all these things, what you get is the maximum speed limit. You get the maximum speed limit, and this maximum speed limit comes out as root of rg mu plus tan theta upon 1 minus mu tan theta. This is the speed limit that you get. Rg mu plus tan theta upon 1 minus mu tan theta. This is with friction. But let's say I don't want to depend only on friction. Even if friction is not there, or I drive it at such a speed that friction is not used. When I don't use friction, or when friction is absent, the rubbing of the tires on the road will be less. So the wear and tear will be less. The life of the tires will improve. So that is why that is called as a good speed for you to drive efficiently without causing your mechanical damage to the tires. That is called as optimum speed. So an optimum speed is where you drive without friction, and then the speed that you get is just rg tan theta. All the formulas look very similar if you notice. When you are going on a flat road, it is rg into mu or mu rg. When you are going on a road which is tilted but you are not making use of friction, optimum speed, this is also called as optimum speed for causing very little wear and tear. So very less wear and tear of the tires. It is rg tan theta, but you are okay with the wear and tear, you want to drive it at the maximum limit, then use this rg mu plus tan theta upon 1 minus mu tan theta. That's the formula. Is that okay? These are the three important cases which you must definitely know. Let's do some questions based on this. An unbanked road has a radius of 45 meters and mu is equal to 0.1, or rather let's say 4.5 meters and mu is equal to 0.1. Question is, find the maximum speed limit. If it is unbanked, that means it is just a flat road. Keep that in mind. It is just a flat road, and when it is a flat road, the maximum speed limit is just given by root mu rg. Mu is 0.1, radius is 4.5, g is basically 10. Okay, 10 into 0.1, 1. 1 into 4.5, or sorry, let me make this one small different number. Let me pick it 0.2. That will give you good answers. 0.2, guys. Sorry. 0.2 will be a better number. So let's say this is 0.2, radius is 4.5, and G is, let's say, 10. So 10 into 0.2, 2 into 4.5 is 9, root of 9 is basically 3. So very small speed, which is 3 meters per second. Now if you go anything beyond 3 meters per second, obviously you will skid. Obviously you will skid. Let's take another example now. Let's say mu is equal to 0.5. Angle of banking is equal to 37 degrees for a banked road. Then question is, if radius of curvature is 10 meters, find number 1 optimum speed, number 2 maximum speed. Two different things, optimum speed as well as maximum speed. How to solve this question? First of all, optimum speed, the formula for that is root rg tan theta. Radius is basically 10. G is also 10. Theta is 37, so tan of 37. 10 times root will be 10. Tan 37 is 3 by 4. So root 4 is 2. So hence I will get the answer as 5 root 3 meters per second. If you go at this speed, it will be considered efficient and optimum, less wear and tear. Yeah. Medic IS, I'm pretty sure you will crack NEET if you are with the right guidance. And please make up your mind whether you want to continue engineering or you want to do medical. Don't be in a confused quantum state. You have to. All the students who are taking partial drop thinking, let's give it for the heck of it. Let me tell you, there are many students like you who will be thinking the same way. So the competition for that also is very immense. Not just that, there are many students who are preparing very seriously. And it is not in 1-2 thousands number. The number is slightly beyond a lakh. So there are roughly a lakh, 2 lakh students who prepare decently, seriously or above average, in the NEET exam. But the most majority of the chunk just give it for the sake of it, or just realize it towards the end, or probably are just giving because somebody else is doing it as a backup and blah blah blah. So the real competition is 1 to 2 lakh students who get a good score. Keep that in mind. So you have to compete against them. Talking about the maximum speed, root of rg tan theta plus mu upon 1 minus mu tan theta. Let's substitute everything. Radius is 10, g is 10, mu is tan 37 is 3 by 4, mu is basically half, upon 1 minus mu is half, tan 37 is 3 by 4. 10 times root is 10, root of 3 by 4 plus 1 by 2, LCM is 4. So 3 plus 2 divided by 4, whole thing divided by 2 4s are 8. So it will become 8 minus 3, whole thing divided by 8. So maximum speed will be 10. 3 plus 2 is 5. 5 by 4. 8 goes on the top. 8 minus 3 is 5. 5 cancels. It will just become 10 root 2. Have you done something wrong? Just check this out. Should come out to be more. Optimum speed can't come out to be less. No, it is fine. Oh, this was 5 root 3. This is 10. My bad. Sorry. This is fine. Nothing wrong. Yeah. Maximum speed. Yeah. So maximum speed is 10 root 2. Correct. No issues. That's how you solve the problems. Now, there were some questions which were asked where train is involved. and then they will tell you, listen, there is one railway track here, there is another railway track here, and they'll tell you, listen, the wheels of the train probably will be like this. So this is one railway track, this is one railway track. There is some distance between the tracks. So the question is, what is this height going to be? So for such questions, don't get scared. If they tell you the distance between the railway tracks, which is L, the distance between the railway tracks, which is L, and they might give you, listen, the track was designed for maybe, something like 72 kilometers per hour, or something like 20 meters per second. Can you find out that height and all such things? So what you will do is, whatever the track has been designed for, that actually becomes your optimum speed. And optimum speed formula is root rg tan theta. So optimum speed, take it as 20, square it, r is given to you, let's say. From this you can find tan theta. Let's say r is, I don't know, something like, again, let's take r as 40 meters, example. Okay, so what will happen is from this, or 40 meters. So from this you can find 200 square is basically 400, is equal to 400 tan of theta. So from this, tan theta is equal to 1. So theta in this case is 45 degree. I know the theta value came out to be huge, but just solving for the sake of it. Once you know theta is 45 degrees, you can easily solve the problem. If the distance between the rails is given to be 2 meters, naturally this is theta. So sine theta is nothing but h by L. So therefore h will be L sine, in this case it is 45, length is 2, sine 45 is 1 by root 2. So this will be root 2, which is 1.41 meters. So that's how you can solve those questions. Is that okay? How to solve these questions? Everyone? Where the difference in the height levels of the tracks is asked or given, and then you have to find the optimum speed. Great. Now that we have done till here, let me focus our attention to one more kind of force, but it is rarely used in some problems. But if used, we will know how to do it. If you remember that we always classified the observer into two types. One is called as inertial, other is called as the non-inertial observer or non-inertial frame. So such an observer, when he or she looks at any object, and non-inertial frame means the frame itself is accelerating, then that person applies a non-real force called as the pseudo force, whose value is the mass of the body into the observer's acceleration, apart from the regular forces which might be acting on it, and the body might have some net acceleration. So then it becomes like mass into acceleration will be your pseudo force plus your other forces, F1, F2, F3, Fn, etc. That is your modified equation. So Newton's laws are not valid, so you make it valid in that non-inertial frame by applying a pseudo or a fake force. Same way, imagine you are on a merry-go-round. Have you ever been on a merry-go-round? Have you ever been on a merry-go-round, guys? It's very interesting. You feel that you are thrown out. Just imagine this. This is our merry-go-round. Imagine there is a pandu over here. As this thing rotates, you feel that you are thrown out. But actually, tell me, are you being pushed by someone? Are you being really pushed by someone? The answer to that, you might feel that yes, I am, but answer is no. Because strictly speaking, any person would try to maintain his line of velocity. So according to the first Newton's laws of motion, this is where your tendency of motion is. This is where your tendency of motion is. But what happens because of the rotation, you are being pulled in this direction. This is your actual path. So there is a difference. I want to go here, but I am going here. I want to study for engineering, but I am studying NEET. I want to become a doctor, but I am studying engineering. So that difference is what causes that force. So you will experience that as if because you're actually going here, but you are pulled or pushed out. This is not real. It is due to your inertia. Due to your inertia. And that outward force is not a real force. It is not real. That is your apparent feeling. So it is pseudo force. It is pseudo force. Such a pseudo force for circular motion is called as centrifugal force. What is it called? Centrifugal force. So remember one thing, a rotating frame is always non-inertial. A rotating frame is always going to be non-inertial in nature. It is non-inertial in nature. Is this understood till this point? Clear? Everyone? What is the meaning of centrifugal force? Okay, you are going in a car. The car is taking a turn. Do you feel that you have been pushed slightly outward? You are in a bus. The bus suddenly turns. You feel that you have been pushed. That is centrifugal force. You wanted to maintain your line, but because the bus turned or the car turned, so your tendency is forward, but the bus or the car moved this way. So the tendency, the inertia pulls you, or you feel that somebody is pulling you. It's not an actual force. This value of the centrifugal force, okay, this value of the centrifugal force, okay, happens to be, I'll show you the value. This value of the centrifugal force, which is a pseudo force, equals to be mass of the body being observed. In this case, I am observing the pandu. So mass of the body being observed, multiplied by omega. This omega is of the rotating frame, omega square, into the distance from the axis. That is the distance from your axis. This is the value of that particular centrifugal force. It is always going to be radially outwards. This is always going to be radially outwards. Is this clear, everyone? M omega square r. Now, I have seen many people comparing this with centripetal force and centrifugal force. Centripetal force is opposite to centrifugal force. Centripetal force has a value of mv square r or m omega square r. Centrifugal force also has a value of m omega square r. That was one of the most stupidest statements that I ever heard in circular motion. Because how can you say centripetal force is opposite to centrifugal force? I know you might be like, sir, centripetal is towards the center. Yes. This is away from the center. Yes. But tell me one thing, do they act at the same time? Do they act at the same time? No. When you are on the ground as an observer, you will be like, oh, frictional force is causing the car to go round and round. So friction takes up the role or the job of centripetal force. Understood? Centripetal force is not a new force, it's just a name given. So friction provides the acceleration, it acts like the centripetal force. But if I'm in the car, then, or I'm in that rotating frame, I'm also rotating as the car is going round and round. I will be like, the world is revolving around me in the opposite direction. I'm a non-inertial frame, so I'll apply a pseudo force. I will be like, how come I can see the car at rest? Just think about it. I'm going round and round like this. I can see the car at rest, right? For me, the world is going around. Car is at rest. How is friction getting balanced? I'll be like, pseudo force is applied. So pseudo force balances friction. The words used, the statements are only different. In a rotating frame, just visualize, just you only rotate and see, you will find that the car is in front of you, the world is going around. So then friction is balanced by centrifugal, but if you are standing outside, you will say friction provides the acceleration. The statements are different. So they are in two different contexts. So they can't just be said they are equal, opposite, wrong. Got my point, everyone? Okay, it just looks like that. Keep that in mind. So that was your centrifugal force. Okay. Now there are many nice applications of it, and especially the vertical circular motion part. That is what we are going to come to. That is the last part of this particular chapter. Okay, vertical circular motion. You might have seen Wall of Death or Hot Wheels track, where a car is sent like this, it goes like that and comes over here. Or a roller coaster goes like this, comes like that without losing contact. So we can understand these concepts using centrifugal force a little bit easily. So if you go very slowly, obviously you will fall down. If you go really fast, then you will not lose contact. So same thing even for a pendulum. See, right now it is a simple pendulum. But let's say I make it go round. Oh, it came down. It was not able to complete the circular path. So if I make it go round and round with enough speed, then it goes without the string becoming slack. And by the way, the charger was flying off. I am little bit careful or else it will break my laptop. If I rotate it slowly, then you will see the string will become slack somewhere. Slack means it is not tight, it is loose, and that mass will come down. So I want to find that enough speed for the complete vertical circular motion, because gravity has a role in it. And what is that critical speed for a string or for a rod or for anything going round and round? That is my main aim. Is that okay? Let's try this out. Okay. First of all, this is your circular track. The most critical point is obviously at the top, because if you are able to cross the top, then everywhere else you will be able to crack it. Okay? Getting my point? It's just like solving the most difficult questions of NEET. If you solve them, then it means you will be able to solve easy questions also. So the most critical point is on the top. Let's do one thing. Let's draw the free body diagram of a mass which is passing by from the top. So the velocity is like this at the topmost point. And now the forces acting on it are, one is mg. And if I'm in the rotating frame, I see that mass like this as it goes up and down. Then I'm a non-inertial guy, so I'll apply a pseudo force. Pseudo force will be outwards, that is Fp. Nothing else apart from that. And yeah, of course, normal. This will be there, normal force. So if I write the equations, now this is not having centripetal tangential because I'm not seeing circular motion. I'm just observing it as it is going up and down. Okay, it's going a circular path. For me, it is at rest. The world itself is rotating. So I'm in a non-inertial frame. So I will say normal plus mg minus, why minus? Because pseudo force is opposite to that, is equal to 0. Okay, fair enough. Therefore, normal will be equal to, take this over here, Fp minus mg. Therefore, normal will be equal to mv square by the radius minus mg. Now, there is a problem. Normal always has to be more than 0. If contact is made, obviously normal should be more than 0. If it loses contact, then normal will be 0. If normal is huge, V is huge, that means you are going with a good amount of speed. But if you have just lost contact, that means normal is 0. That means 0 is equal to m, that minimum velocity at that top, square by the radius minus mg. Mm will cancel. Therefore, velocity at that top, square divided by r, is equal to g. So that velocity at that top will be root of rg. That is the important looking formula. So the velocity at the top is nothing but root rg. If you go beyond this speed, then you are safe, contact is made. Anything less than this is the problem. Equal to it, no issues, normal will just become 0, but again it will make contact at the next point. You will still be able to continue. So below this is a problem, above this is not a problem. Now you will be like, sir, okay, fine, got it. But you know, sir, the problem is not there. The problem is also at the bottom as to how much speed will I give it so that it reaches the top with that much speed. Obviously, I have to give it some speed only, then it will reach here with that speed, and that speed will be definitely more than root rg. So how to solve that question is what you might be thinking. So this same mass over here needs some speed so that it is able to reach here. That I need kinetic energy, work kinetic energy, or energy conservation principle. So from the bottom, whatever kinetic energy was there, that got converted into kinetic energy at the top and some potential energy at the top. The kinetic energy at the bottom was half mu square is equal to kinetic energy on the top was half mv square. Potential energy is mg. This height is the diameter. So mg into 2r. Mm cancels. So u square multiply by 2 actually. So 2v square plus 2gr. Wait a minute. Oh, sorry. This 2 will also not be there because half is there. So just v square. But the velocity at the topmost point is root rg. This is velocity at the top is root rg. So root rg square plus 2gr. So it will be rg plus everything fine. And I think I missed one 2 here while multiplying. So sorry guys. I multiplied by 2. So 2 times g into 2r. M was cancelled. So this will become 4gr. So 4gr over here. So this will just become 5 times of gr is nothing but u square. Therefore, u will be root of 5gr. If you give that much speed, it will reach the top with root gr speed. Then you are safe. By the way, this also works for a pendulum kind of a thing which is made of string. This is a string. This is that mass which is given that speed. This is that bob, you can say, which is given that speed. So it goes up, reaches here. It has to complete the entire circle. So that means here also it should have some decent speed. That decent speed will be root rg, so that your mg is being balanced by your pseudo force when the tension just becomes 0. This is that critical speed where the string just loses the tension, but next instant it will gain it back. So anything less than this speed, tension will not be there even much before. So it will go down here only. So here the speed at the bottom should be obviously root 5 rg. Root 5 rg. Just like the normal problem of this particular track. Hot Wheels or a person going round and round or the well of death. All these things. So both of them have similar theories, similar formulas. Root rg on the top, at the bottom it is root 5 rg. Is this clear, everyone? Yep. But there is a catch in this, and the catch happens when the pendulum is such that it is made of a rod. See, if you take a string, right, if you pull it from both sides, the tension is there. But if you leave it, it will just be like this. The tension will be zero. It will be basically slack. But the same thing is not applicable for a rod. You take a rod, by the way, this was a rope. Now this is a rod. You pull the rod from both sides, you will see that there is tension. But if you leave the rod as it is, if you leave that particular rod as it is, it will stay there. It will not become slack. It can't be slack. So even if my velocity is 0.01 meters per second, as I am passing from the top, I will be able to pass the top because the rod will never go down like this. Just imagine this bob, I can hang it from the ceiling. But can I do the reverse? Imagine, can I do the reverse? Can I hang it like this? This is a rope, this is a string. It will become slack, it will fall down. But the same thing can be done using a rod or a column. That has no issues. It can not become slack. So therefore, the velocity at the top is negligible. Anything more than 0 will work. Therefore, at the top, velocity should be any number more than 0, okay, to cross it. Even 0.001 meters per second will be okay. For the bottom, what you will do, again apply energy conservation. Kinetic energy at the bottom will be potential energy at the top because kinetic energy will become negligible. It is negligible for the critical case. So the potential energy at the top is mg into the total height is 2r. Kinetic energy at the bottom is half m v square. Mm cancels. So v square will be 2 times g into 2r. So it will just become 4gr. So the velocity will become root 4gr. This is true for rod pendulums. What is it true for? Pendulums made of rod. For string pendulums, the answer is this one. So very, very important. This is a string pendulum. This was a pendulum made of rod over here. The mass is attached. Clear, my dear students, how this works? Very, very important. Correct. Awesome. There are some interesting questions also on pendulums like this, where if you leave the pendulum it goes here like this and again begins to decelerate until it stops again. These two end points are always called as the extreme positions, and the point in the middle is called, middle means mean position, So this is a simple pendulum which is oscillating. So oscillating pendulum. So there are some interesting things which can happen at the mean position versus the extreme positions. Like, let's talk about the velocity. Let's talk about the velocities. At the mean position, the velocity will be maximum because all the potential energy got converted into kinetic energy. So the velocity at the mean position will definitely be maximum. If you talk about the centripetal acceleration and the tangential accelerations, then what will happen? Just one second. Centripetal and the tangential accelerations. At the bottommost point, centripetal definitely is there over here. Definitely centripetal is there. Centripetal is definitely present. But tangential is not present only because at the mean position, mg is downwards, tension is upwards. There is no force only to give the tangential acceleration. So tangential acceleration is absent when it reaches over here. If you talk about angular velocity is also maximum over here. This is also maximum over here. Because tangential is 0, at that position, alpha is also not there. Alpha, angular acceleration, is also not going to be there. Similarly, for extreme positions, at this point or this point, you just stop over there. So the velocity just becomes 0. In fact, that is the least value that you get. At this point, even omega becomes 0 because you stop before turning back. But at these points, a very interesting thing happens. Because your velocity is 0, v squared by r will be 0. So centripetal acceleration won't be there because think about it, AC is v square by r, that means it is 0 square by r, that means it is 0. So there is no centripetal over here. So there is no centripetal here, but there is tangential if you notice. How? Because mg is there, mg's component will provide that acceleration. Yep, tension is there, no worries, but tension will not affect tangential. Along the tangent, mg's component gives that. So that is why tangential is there, centripetal is not there. Centripetal is not there. Tangential is there, even alpha is going to be there. Is that okay? This is something which you should basically know regarding the parameters. If you write any equation at the mean position, how will it look? Observe carefully. Tension is in the direction of acceleration. So tension minus mg is m into AC. Centripetal acceleration is there. In fact, it is maximum speed square divided by the length of the pendulum. Okay, so this will be T minus mg. If you go to the extreme position, then mg's component is giving that. So let's say this is theta. So mg sine theta is mass into tangential acceleration, or tangential acceleration will be g sine theta. And in that direction, also what is mg cos theta doing? It is balancing tension. So tension minus mg cos theta will be 0, or tension will be equal to mg cos theta. These equations will come if forces, tension, centripetal accelerations, tangential accelerations, etc. are asked. So if you know this slide, how it comes, you can solve any question. They can ask you tension, what is it here? What is the speed here? What is the centripetal acceleration here? What is the tension at mean? So use these equations to solve these questions. Is that okay? Have you got a better understanding of circular motion? That is what the most important thing is. Yep. Everyone? Clear? If you look at some NCERT questions also, you will be easily be able to solve it. Say for example, this one. Insect is trapped in a circular groove, steadily completes 7 revolutions in 100 seconds. What is the angular speed, linear speed of the motion? Is the acceleration vector a constant vector? What is the magnitude? So say for example, you want to solve this NCERT questions. Okay. Radius is given to be 12 centimeters, means 0.12 meters. 7 revolutions in 100 seconds. You can find omega. 7 revolutions is 7 into 2 pi radians in 100 seconds. So basically this goes with this 50 times. So 7 pi by 50. Pi is 22 by 7. So 22 by 7 and 50 over here. So it will be 22 by 50 radians per second. So you can find omega. Now you can find anything else that is asked. For example, what is the angular speed? Done. Angular speed we already figured out. Linear speed will be r omega. Done. Is the acceleration a constant? What is the magnitude? Well, in a circular path, obviously the centripetal acceleration keeps changing the direction. Direction changes. The direction changes. But the magnitude is constant. The magnitude is constant. The magnitude of the centripetal is v square divided by r, or omega square r. I know omega, I also know the radius. Substitute it, you will get the answer. Very, very straightforward. Very, very straightforward. That is exactly what they have done. Okay, that is exactly what they have done. All right, radius is given, velocity they have asked, and acceleration also they have found. The magnitude is constant. Is it clear? Yes. Similarly, any other question which is there in NCERT, like this. A circular track of some radius is banked at 15 degrees, friction is given, optimum speed and maximum speed. So for optimum speed, we will just use root rg tan theta. R is 300, g is 10, and basically tan of 15 degrees. For maximum speed, the formula that you will use is root r into g into mu plus tan theta. So 0.2 plus tan 15 and 1 minus 0.2 into tan 15. Tan 15 value they should give you, or you can, you can use the tables which is given to you in the exam. Okay, some data point will be given to you and then you can solve the question. Otherwise, finding tan 15 will be a task in itself. You have to use double angle formula and all of that. So usually in NEET exam, they'll give such values. So don't break your head, sir, how do I find tan 15? Okay, it will be given to you. Same thing they have done over here. So you can see the questions are very, very simple and straightforward. Another question is, angular speed is increased from this RPM to this RPM in 16 seconds. What is alpha and how many revolutions does it undergo? See, here you know original speed is 1200 RPM. So you multiply by 2 pi divided by 60 to get it in radians per second. You know final also 3120 multiply by 2 pi divided by 60 radians per second. Time 16 seconds. You have to find alpha and you have to find delta theta. So there are two kinematic equations which will do your job. So omega final is omega initial plus alpha into t. I know time, I know this, I just need to find this out. So find alpha. The next step will be to find the number of revolutions. Omega final square is omega initial square plus 2 alpha delta theta. Whatever you get over here, substitute it. Whatever alpha. This you know, this you know, this you have to find. That's it. Isn't it simple, guys? Yep. Krishna, practice sessions probably from November onwards. Yeah. So we'll try to complete everything by that time. That is what they have also done. Number of revolutions, whatever radians you get, you divide it by 2 pi. Whatever radians you get, divided by 2 pi. The same thing they have basically done. So basically we have completed this particular chapter, my dear warrior, circular motion. So, yep. We have done all kinds of questions, we have done all kinds of practice, we have done the theory part of it, vertical circular motion, uniform circular motion, conical pendulum, simple pendulum, complete circular motion, what is the speed required, banking of roads, unbanked roads, centripetal centrifugal force concept, basic terminologies, omega, alpha, tangential, centripetal, all these things. That's all circular motion is. Weightage wise, it is a low weightage chapter, but if you don't understand circular, you can't understand rotation. And you know rotation is important. Cool? So also circular motion concept comes in alternating current, simple harmonic motion, interference of waves and all of that. So it is a very useful chapter in many places. Okay? Any doubt? Please ask me in the comments. Anything else you want to ask me? Yeah, feel free to ask. But mainly also smash the like button, subscribe and practice at home from Tatva book. And I hope you have also ordered the flashcards and you are revising through the flashcards. They are super duper amazing. Check out the video which is there on the channel. And if you have forgotten to register for NVSAT so that you can get scholarships, please do that, because the scholarship test is going to come up very soon and I don't want you to miss those scholarship examinations. Yep, it's right over here, NVSAT scholarship test. Okay, if you have not yet bought Tatva books, you can buy it from here. The DNA batch is still running. If you want to join late, it's okay. You have missed some classes, you can watch the recordings later on. Every single thing is given to you. Your treasure box is right here, which is a collection of all the lectures, everything in a beautiful manner. With the PDF, the notes, chapter-wise PYQs, everything is there for all of you over here. Scholarship test link is there over here. Lots of rewards to be won. Online, offline mode. Enter your number, get the OTP, register for it. Okay? So, use everything guys. Everything is there on the plate. It's like a buffet. If you don't eat it, then you will be at loss. You'll be like, oh my God, sir had told about this batch, sir had told about this book, sir had told about this scholarship, sir had told about flashcards, sir had told to watch the classes, sir had told about treasure box, and I only didn't use it. You will feel bad. Now is the time. Make the best use of the time that you have. Okay, there are still many months to go. Once the syllabus is done, you will see lots of practice sessions coming through. Okay, take care. Bye bye. Hasta la vista. Thank you for liking.